Good morning, students. In the last class, I have started the second topic of Module 4, that is Process Framework. In that, I explained the basic principles. There are six basic principles: sensitivity, redundancy, restriction, partition, visibility, and the feedback. So, this is not mentioned here. So, they have mentioned just chapter 17 and 20, but two more chapters are there for process framework. One is chapter 3 that consisting of basic principles, and the other chapter for the quality process planning and monitoring, that is chapter number 4. So today I'm going to start the chapter number 4 for the quality process planning and monitoring. So in this you are going to study about what is the quality process, then you are going to study about quality goals, dependability properties, analysis, testing, improving the process, and organizational factors. So today we'll start that chapter, that is test analysis activities within a software process. This is chapter number 4. Okay, so yesterday I covered chapter 3 and this is chapter 4. Please inform your friends about these two chapters because these two are not mentioned in the syllabus copy. Okay, okay na Miss Ba, inform ಮಾಡಿ ನಿಮ್ಮ ಫ್ರೆಂಡ್ಸ್ಗೆ.
Yes, ma'am.
Okay, so it is the new chapter, test and analysis activities within a software process. So in this chapter, you are going to study about the role of quality in the development process, then building an overall picture of the quality process, then identifying the main characteristics of a quality process, such as the visibility, anticipation of activities, and the feedback. Okay, so first we'll start with why do we require the test and analysis activities, whether the testing and analysis can be done in the beginning or throughout the software development process or at the end, that we need to know. Okay, so as we know, commonly when we say that testing and analysis, normally we think that once the system is developed, finally we are going for the testing process, but that is not the case, because the testing and analysis activities should occur throughout the development and evolution of software systems. Okay, so testing and analysis activities must occur throughout the development and evolution of software systems, starting from the requirement engineering through the delivery and subsequent evolution, or we can say starting from the requirements collection and design and implementation, and finally we'll move on to the maintenance phase. So in all these steps or all these processes, the testing and analysis must be there, because if this is not the phase, and means the testing is not a phase, it is a lifestyle, and this lifestyle we have to follow throughout the software development process. So throughout the software development process means the software development process consisting of different steps. First one is the requirements collection, next is requirement specification, design and development, and finally implementation, and finally the once the system is implemented, then we are delivering the system to the end user or to the customer by identifying whether the developed system is meeting the user's requirement or not. So in these phases we have to perform the testing and analysis, because we need to identify or we need to detect the faults, and we have to correct the faults at the earlier stages itself. As I explained in the last class, if we are detecting the faults and correcting the faults as early as possible, then cost will be very very small. But as we fail to detect the faults during the earlier phases of the software development, and if we are detecting the errors during the system testing or the integration testing or at the user's site, then correcting the errors will become very very costlier and also time consuming one. So hence we need to detect the faults at the earlier stages itself. So to detect the faults, we need to go for testing. So hence testing can be done not only at the end, but it should be followed throughout the development of the software. Then we'll see the software qualities and the process. And as we say, whenever we are developing the product, we want some quality, right? And this quality cannot be added once the software or the system is developed. So it is also a continuous process. So through this testing and analysis, we are identifying the faults, or we are detecting the faults and correcting the faults. Along with that, we're also checking for the quality, whether the uh, designed system or designed software or implemented software is meeting the defined quality or not. That we have to check, because that quality cannot be added after the system development or after the software development. And this quality results from a set of interdependent activities. And whenever we are trying to perform the, or whenever we are concentrating on the quality of the software, we are checking that through the analysis and testing. And this analysis and testing is a crucial part in the software development, but that is not the only one that is sufficient. That is not sufficient for assuring the, or for the software quality assurance. The essential feature of software process is that software test and analysis is thoroughly integrated and not an afterthought. Means we have to perform the testing and analysis, and we have to assure the software quality throughout the system development, and it should be thoroughly integrated, and not after the end of the product, or not after the system or the software is developed. So quality is needed. Software quality is very very essential factor, and that can be achieved through the analysis and testing. But this, the analysis and testing is not the single one, but it is the essential one. Along with that, we have to go for other measures, so that the software quality can be assured. Next, we'll see the what is the quality process. And so next we'll move on to the what the interactions and the trade-offs and the properties of the quality process. So first we need to know what the quality process. So first we have to identify the particular activities and the responsibilities in the software development process, so that we are focusing on ensuring the adequate dependability of the software product. As I said, see here, the quality results from a set of interdependent activities. Means we need to ensure the adequate dependability of the software product. So to do that, we have to identify the particular activities and the responsibilities. Understood? In order to achieve the dependability, or in order to achieve the interdependent between the different modules, we have to identify a set of particular activities and responsibilities. Through that, we can achieve the dependability. And so here we are to achieve this, we are identifying the set of activities and the responsibilities. And the quality process primarily focusing on ensuring the adequate dependability. And here we are concerned with the project schedule, or with the product usability. So project schedule, as I explained in the last chapter, so in the visibility, so we need to identify the project goals, and we need to plan the we need to have the proper project planning. So then, when we are moving through the different software phase development phases, we need to check whether we are with the given the schedule, or ahead the schedule, or we are lagging the schedule. That we have to check at each stage of software development. Hence, we are dealing with or concerned with the project schedule, and also of the product usability. Because once the product is developed, that can be should be properly used. If it is not properly usable, then the that particular product uh, leads to failure, right? So the product usability means we want the product to be operated, or the software to be operated according to the user requirements. Then we say that the product is, or the software is usable otherwise not. Then it leads to failure. Then that we need to avoid. So how we are avoiding that? Through the assurance of the quality process, and the quality process is, our quality is assured through the different software development process. And the quality process provides the framework for selecting and arranging the activities aimed at a particular goal. So for example, if you have implemented one program, so what is the main goal of that program? Suppose if you consider the triangle problem that I explained in the previous chapters, right? Triangle problem. In the triangle problem, what you are going to do? You are going to identify whether you can construct the triangle or not by considering the sides of the triangle. And after that, if it is possible to construct the triangle, then you are going to check whether what type of triangle you are going to construct, whether it is isosceles, scalene, or one more is uh, three types of triangles, right? Isosceles, scalene, which is the other one? Equilateral triangle. Okay, so we have to check whether the triangle is equilateral, isosceles, or the scalene triangle. To do that, that is our main goal, right? We have to construct the triangle and we have to identify what type of triangle it is. So that is the case, right? Selecting and arranging the activities. So here, to implement that program, or if you consider implementing a particular software, then you have to check whether that is meeting the given goal or not, that you have to assure. And next, considering the interactions and trade-offs with other important goals. So not only so when you are developing or implementing the system or the software, you are defining the different set of goals. We are not only concentrating a single goal, we are defining set of goals. Then we have to check whether all the goals will be all the goals are met or not. So to do that, we have to consider the interactions and the trade-offs with other important goals. So this is about the quality products. So then here, as I said, we have to consider the interactions and the trade-offs. We'll see what are the interactions and trade-offs with respect to high dependability and versus time to market. So high dependability. So for some of the products, we need more dependability, and some of the products we need the time to market. Time to market means we have to develop the product as early as possible, and that product should be released to the market as early as possible by taking less time. Right, that is called as time to market. But in the case of high dependability, we want the high dependability, but that may take more time for the software development. So in the high dependability, we are not only concentrating on the dependability, not in the how much time it takes for the software development or the product development. But in the case of time to mark, we are concentrating on developing the product and releasing the product to the market as early as possible. Okay, so we'll see the mass market products, that is time to market. For that, we are considering the mass market products. Here, we are concentrating on achieving a reasonably high degree of dependability on a tight schedule than to achieve ultra high dependability on a much longer schedule. So because here we are considering, or we are concentrating on developing and releasing the product to the market as early as possible, means with less or within the given time, or by using lesser time, we have to develop the product and that product should be released to the market. But in the case of critical medical devices, because the medical devices are very very important in treating the patients, right? So for that, we need the ultra high dependability rather than the tight schedule, because these devices cannot be produced by using lesser time, because it requires more time, because we need to assure the maximum quality for the medical devices. And hence in the for critical medical devices, we our main goal is to achieve the ultra high dependability by using more time for the software development. Understood? So critical medical devices better to achieve ultra high dependability on a much longer schedule than a reasonably high degree of dependability on a tight schedule. As I said, the quality process is structured based on different properties. The properties of the quality process are completeness, timeliness, cost effectiveness. Okay, these are the three important properties of the quality process. One is the completeness, second one is timeliness, and third one is the cost effectiveness. First we'll see what is the uh, completeness. Next we'll move on to timeliness and cost effectiveness. So first one is the completeness. Completeness means appropriate activities are planned to detect each important class of faults. So as I said, we need to detect the faults at each development stage. So to detect the faults, we need the appropriate activities and the responsibilities. So completeness defines the appropriate activities which are planned to detect the important class of faults. So at each stage we need to identify the different faults. For that we are making use of the different activities and responsibilities. Next one is timeliness. Here, the faults should be detected at the point of high leverage, and these faults should be detected as early as possible. Why? Because if the faults are detected at the earlier stages, and correcting those faults is also easier, and the cost is also less. Because if the faults are left undetected and they are detected at the system integration stage or at the user side, then detection and correction of the faults are very costlier. And hence timeliness, the main goal in timeliness is we have to detect the faults as early as possible in the software development process. Next one is the cost effectiveness. Here the activities are chosen depending on the cost and effectiveness, because see, some of the activities which are effective and they are very costly, then selecting such type of activities is not the wise thing. Hence we have to select the activities and the responsibilities in such a manner that those activities are effective and also the cost is minimum. So these things we have to consider in selecting the activities for each phase. So here the cost must be considered over the whole development cycle or and for the product life. So the cost is the very important factor. We have to develop the good quality product with the minimum cost, right? And that is applied to the whole development life cycle. And here the dominant factor is usually the cost of repeating an activity through many change cycle. Because here, once you define or identify the activity, and that activity can be repeated uh, throughout the software development life cycle. Understood? That is the main dominant activity, or the dominant factor we can say, because the cost of the repeating an activity through many cycles should be minimum. So these are the properties of the quality process. So here the exam or the test they may ask, define quality process and what are the different properties of the quality process. So first you have to define what is a quality process, then you have to define the different properties of the quality process. Next we'll move on to the planning and monitoring. So during the software development process, we need to have the proper planning and we need to monitor the software development process. For that, to ensure the quality of the software. Okay. So here the quality process balances several activities across the whole development process. Across the whole development process means we are considering the entire software development life cycle, and the quality process balances the several activities which we are using during the software development life cycle, and this selects and arranges them to be a cost effective as possible, and it improves the early visibility. So in the last class I explained what is the visibility, right? So here by using the quality process we can improve the early visibility. Then what is the visible or the visibility? A process is visible to the extent that one can answer the question, how does our progress compare to our plan? Means before developing the software we have the plan. Then during the each stage of the software development we have to check whether we are according to the given plan or not, or we have to identify whether we are on the schedule or far ahead the schedule or behind the schedule, that we need to identify, and that is called as the process visibility. And so whenever we are achieving the quality, and these quality goals will be achieved through the proper and careful planning of the process. Okay, the quality goals can be achieved only through the careful planning and the implementation of those plans. Okay, so hence the planning is integral to the quality process. If the quality process has not achieved the adequate visibility, if one cannot gain the strong confidence in the quality of the software system before it reaches the final testing, because we need to achieve the adequate visibility through the quality process. If not, then we cannot get the confidence in delivering the quality product to the users or to the customers. And the quality activities should be implemented or should be followed as early as possible. Means we have to implement or follow the quality activities from the first stage of the software development. From the first stage means during the software requirement collection itself, our specification requirement itself, we have to follow the the quality activities. And design test cases at the earliest is the better it will give the earliest opportunity, because we have to define the test cases at the earliest stages itself, not during the end of the product development. So the design test cases should be defined at the earlier stages itself. And the users analysis techniques on software artifacts produces before the actual code, and this motivates the use of the Fraxi measures. For example, if you consider the number of faults in the design or code is not a true measure of the reliability, because if more number of faults exist, then also in some cases the system works better. And if then a number of if no faults are detected during the software development, but it may leads to failure when the customer started using it. Hence, the number of faults in the design or code is not a true measure of the reliability, but we may count faults discovered in design inspections as an early indicator of potential quality problems. We'll see the analysis and testing strategy. This analysis and testing strategy identifies the company or the project-wide standards, and these standards must be satisfied by the developed product or the software. To do that, we are following the procedures for obtaining the quality certificates required for certain classes of products, and we are using different automated and manual techniques and tools for analysis and testing. And during the analysis and testing we need to produce the documents. The analysis and testing plan consisting of different steps. Those are the objectives and scope of the analysis and testing activities, documents and other items that must be available, items to be tested, features to be tested and not to be tested, that we need to identify. Then analysis and testing activities, staff involved in the analysis and testing activity, what are the constraints, and the pass and fail criteria. Pass and fail criteria means when you are applying the testing and analysis activities, you have to check whether your designed system or developed system is pass or failing those activities. Next, the schedule, deliverables, hardware and software requirements, and what are the risk and contingencies exist in the analysis and testing plan. So these are the different steps you need to follow in the analysis and testing plan. So in the exam, they may ask, explain the different steps involved in analysis and testing. A&T indicates analysis and testing plan. Okay, so these are the different steps you need to write. Next one, we have the quality goals. So in the quality goals, as I said, we need to define the quality goals before the software development starts. And the process visibility requires the clear specification of the goals. See here, when we are concentrating on the process visibility, then this process visibility requires the clear definition of or clear specifications of the goals. And the this process visibility includes a careful distinction among the dependability activities or dependability qualities. Means we need to identify the distinction or the difference among the dependability qualities. Then the team exists for performing that. So it does not, if the team does not have a clear idea of the difference between the reliability and the robustness, then it leads to the failure of the project or failure of the system. So here we have two different types of product qualities. The qualities which are visible to the users are called as the external qualities, and the qualities which are within the organization or which are not visible to the users are called as internal qualities. So here we have two types of product qualities. One is internal qualities, second one is the external qualities. External qualities are the qualities which are visible to the users or to the customers, and the internal qualities are not visible to the user or the customers, they are within the organization. And once again, in external qualities, we have two different types. One is the usefulness qualities, and second one is the dependability. Under usefulness qualities, we have usability, performance, security, portability, and interoperability. For the dependability, we have the correctness, reliability, safety, and the robustness. So these are the useful qualities and dependability under the external qualities. And for the internal qualities, we have the maintainability, because the maintainability primarily affects the development organization and indirectly it affects the customer or the user also. So that is not visible to the user, maintainability which is not visible to the user, but indirectly it affects the user. And this is a very very important factor or the primary factor that affects the product development. So this is about the quality goals. We have useful qualities, dependability in external quantities, and internal qualities. So dependability qualities, as I said, correctness, reliability, safety, and robustness. So that we'll discuss in the next class. Dependability properties are the dependability qualities. What is correctness, reliability, safety, and robustness? That we'll see it in the next class. Uh, any doubt in this, Misbah?
No, ma'am.
Gaurav?
Ma'am,
Gaurav?
Gaurav left only.
ಕ್ಲಾಸ್ಗಳನ್ನ ಅಟೆಂಡ್ ಮಾಡೋದಿಲ್ಲಪ್ಪ ಸರಿಯಾಗಿ. ಓಕೆ, ಡೌಟ್ ಇದ್ರೆ ನೀವು ಕೇಳ್ಕೊಳ್ಳಿ ಆಮೇಲೆ. ನೌ ವಿ ಆರ್ ಹ್ಯಾವಿಂಗ್
Okay.
ಅನದರ್ ಕ್ಲಾಸ್, ರೈಟ್?
Yes, ma'am. .NET class.
Okay, then you connect that. Okay, I'll end the
Okay.
class.
Okay, ma'am.
Okay.